So let's begin. So Wi-Fi 6E, we'll talk about the benefits. The speed, capacity, and reliability are really proving to be the most powerful Wi-Fi technology yet. We'll we will also introduce our ECW336 Wi-Fi 6E access point, which is our first innovation entry into the 6 gigahertz realm. So we'll briefly talk about the benefits of Wi-Fi 6E, and then we'll go right into the EnGenius solution, and then we'll open it up for any questions, and we'll attempt to answer those questions. So the first thing I'd like to talk about is, what is Wi-Fi 6E, or some of the benefits of Wi-Fi 6E. Wi-Fi 6E is basically 11AX operating on a new frequency band, which is 6 gigahertz. What that provides is greater capacity. That's one item. The 6 gigahertz spectrum is more than double the 2.4 and 5 gigahertz spectrums actually combined. So it's boosting or allowing 7 brand new 160 megahertz wide channels to the mix. So that's a lot. So anytime you're trying to gain more speed through Wi-Fi, you need in some cases, you widen the channel selection, and you can do that to 160 megahertz. And in Wi-Fi 6E or 6 gigahertz, you have 7 channels to choose from, which is really important to understand. In smaller deployments, you can now start to alternate channels on 160 megahertz wide channels. So that's a huge benefit. Another one is more efficiency. 6 gigahertz traffic will benefit from the spectrum management and efficiencies of Wi-Fi 6. So what I'm saying is 11AX or Wi-Fi 6 is now operating on 6 gigahertz, which is a new frequency band. So there's two differences there. We're calling it Wi-Fi 6E, and that is 11AX running on 6 gigahertz, a brand new frequency, newer than 2.4 and 5 gigahertz. So a whole brand new frequency for us operating in using the high efficiency 11AX. So this is really free from interference from basically 2 decades of legacy devices that are operating on 2.4 gigahertz and 5 gigahertz. So this is a game changer for us, right? For the Wi-Fi industry just in general. So you will see higher performance. We've tested and we've received multi-gigabit speeds and ultra low latencies. And this can be perfect for, gaming, augmented virtual reality, robotics, and other latency sensitive applications. So there's a lot that can be done in this new frequency band, and it's going to be helpful to the industry. So just to kind of really amplify how important 6 gigahertz is, you can see from this graph here, we have 2.4 gigahertz and 5 gigahertz. EnGenius and other companies have been operating in unlicensed band for over 23 years now in 2.4 and 5 gigahertz, and we've done literally thousands and thousands of networks, probably millions of networks in this frequency band in 2.4 and 5 gigahertz. And you can see how large 6 gigahertz is in comparison to 2.4 and 5 gigahertz. So it opens up the door for a lot of different things, or a lot of new things, and being able to pass higher traffic and doing a lot of virtual reality, metaverse applications, all types of things that can be done within this new frequency, and how much room we have in this frequency band. So Wi-Fi 6, it will alleviate the problems of network congestion and solve the problems related to crowded office environments for sure. Wi-Fi 6 will improve the responsiveness of cloud and collaboration applications and allow teams to enjoy the fastest speeds when sharing, backing up, and updating files. So, we're starting to see that now, where in our testing, the amount of speed that we're getting in regards to sharing files and backing up and so on. So there's a lot can be applied to this new frequency band. Wi-Fi 6 will support larger bandwidth loads, processes faster multi-gigabit data, achieves low latency, provides reliable and secure connections. Everything operating in Wi-Fi 6E on 6 gigahertz will be using the latest security which is, or wireless security, I should say, WPA3. It won't be using WPA2, but WPA3. So everything operating within that frequency band will be newer generation products with newer generation security, such as WPA3 or WPA3. WPA3 and WPA3 Enterprise, to be a little more specific. So a lot of it'll be more secure within that realm and operating with newer devices. And you will not have 2.4 and 5 gigahertz, obviously, operating in this band. So Wi-Fi 6 will meet the demands for, like I said, larger bandwidth for real-time mass transmissions required for augmented reality, virtual reality, and metaverse applications. The one takeaway from this particular screen, which I think you probably already see, is you have 7 160 megahertz channels. That's really, really wide channels. You have 59 well, if I start from the bottom and work my way up, 760 megahertz channels, 14 80 megahertz channels, 29 40 megahertz channels, and 59 20 megahertz channels. So a broad range of channels to be able to work with. I'll give you an example. Right now in our office, it's about 10,000 square feet. We have 5 access points. They're operating on 40 megahertz. If I could bond those channels and work on at 80 megahertz, the performance within Wi-Fi would be heightened extremely, as long as we have the ISP speeds to handle that. But yeah, I could increase the wireless throughput dramatically, moving from 40 to 80 and even 80 to 160. I have 7 channels, so I don't have to worry about overlapping channels and things like that. But there are problems when you start bonding channels. So the noise noise raises as you increase the when you start bonding channels, I should say. But a lot of channels to choose from operating in 6E. So a lot of great benefits with Wi-Fi 6E, and a lot of benefits with having this new access point, which is the ECW336. It's our Wi-Fi 6E access point. We're actually seeing a lot more demand than what we imagined. I mean, I always thought that a lot of customers would tend to use this and implement it into business networks, enterprise networks, but there's more demand than what we anticipated. So this particular device, the ECW336, the MSRP price will be $699. It is a cloud managed Wi-Fi 6E access point. It's a tri-band access point, so it does operate on 2.4 gigahertz, 5 gigahertz, and 6 gigahertz. And most of your devices, or all of your devices, will onboard via 2.4 and 5 gigahertz. And if they're 6 gigahertz, if they support 6 gigahertz, they'll be transitioned over to the 6 gigahertz radio. But they will onboard on 2.4 and 5 and then be moved over to the 6 gigahertz and be able to utilize the 6 gigahertz wireless connectivity and all the things, benefits that come with it. We continue to use Qualcomm quad core CPU. We have direct relationships with Qualcomm. We have had relationships with them for a very long time now. All of our access points use this particular CPU. This is a newer version of the CPU. Obviously, operates on those 3 bands. Just to give you some ideas on the theoretical speeds, on 2.4 gigahertz, you'll see up to 1.1 gigabit, which is tremendous. That's really, really fast. These are theoretical. Keep that in mind, theoretical speeds. On 5 gigahertz, you'll see up to 2.4 gigahertz of speed. And on 6 gigahertz, you'll see up to 4.8 gigahertz of speed. They're all theoretical speeds. Just to give you an idea, we had a webinar. You may have missed it. There's a recording that you can go to the YouTube channel and see that particular webinar, but we talk about what our actual throughput speeds were on this particular device, and they were over a gigabit of speed for particular devices. For 2x2 Wi-Fi 6E client devices, such as my personal laptop, which is a Lenovo T14, has a Intel Wi-Fi 6E client radio inside of that, I can see over a gigabit of speed on the wireless side with this particular device. So you can see a lot of great speeds with this access point. This is a 4x4 antenna design. So 4 antennas for 2.4, 5, and 6 gigahertz. The Ethernet port on this particular device is 5 gigabit Ethernet port. It is PoE plus, so it's 802.3 AT compliant. It will operate with any PoE plus compliant switch, any of our cloud switches, minus the ECS 1008P. That's an AF switch. So it will operate with any AT compliant switch or any AT compliant PoE injector, such as the EPA 5006 GAT. That's an AT compliant PoE injector that can be used. The radio output power for all 3 radios is up to 23 dBm. So you can punch up the output power on the particular radios if you need to. Typically, we go to auto, or we'll adjust them down to work with client devices like smartphones, as an example. The antenna gains on 2.4 gigahertz is 5 dBi. On 5 gigahertz, it's 6 dBi, and on 6 gigahertz, it's 5 dBi. So that's the dBi gain of the antenna that's in antennas that are integrated into this particular device. These are obviously FCC approved, CE approved, and IC approved or compliant. And they all cloud access points and switches, for that matter, have a 2-year warranty. So again, this is a product intro and this highlight of the spec for this particular access point. So as I mentioned, this is a cloud managed access point. So let's quickly touch on the local configurations of the ECW336. So it does have a local GUI or graphical user interface, but you shouldn't need it or make any changes here. When I connect directly to this access point through an Ethernet cable from my laptop, go into a default IP address, this is the screens that I would see. There's 2 variances of the screens, or 2 tabs for the screens. There's local settings and device settings. Local settings give you some high-level changes that you can make. You can actually do a firmware update from here. You can change the management VLAN from here, static IP addressing from here. The other screen, which is the device status screen, will tell you if it's actually communicating with the cloud interface or the cloud portal. And it gives you the IP address and so on. So it gives you some connectivity information on these particular screens. The only time you would really go into the local interface of any of the cloud access points, including this particular access point, is to troubleshoot this access point. There's no other reason to do that. Even the firmware updates happen through the cloud, so you don't even need to do firmware updates. In fact, we don't even list firmwares on the product pages on our website. It can all be done within the cloud, and it can be done through an automatic scheduling process. So that's done automatically. You don't even have to worry about that. So typically you would not even have to go into the screen unless it cannot reach the cloud for whatever reason. And typically we can figure those things out. And the one thing that Eddie and I have ran into multiple times is either DNS or it's a layer 1, like a cabling problem or a power source particular problems. But there's really there shouldn't be a reason to go in here too often. But it does have a local interface, and I wanted to talk about that really quick. So everything really happens under the cloud management interface. That's EnGenius Cloud. So this is a cloud managed access point. So everything can be done by the cloud graphical interface or through the mobile app. I will try to show you a quick demo of the interface, of both interfaces of the particular, the EnGenius Cloud app and the EnGenius Cloud just in general. But EnGenius Cloud Management allows you to drill down to specific access points. And you typically start from this standpoint from your dashboard, and you can quickly click into access points to get a little more granular. So I can click on the access points. It will give me a list of access points. And so I start from either an organization level or like a customer level, and I start to drill down to particular devices. So this particular screen, I'm looking at all my access points, and I can click on any of these lines to gain more information about a particular access point. But if I click again, I can go in even deeper and look at some diagnostics of the access point in itself. So I can continue to drive down into an access point and look at a majority or a lot of information in regards to how the access point is performing, how the if I need to troubleshoot a particular access point. It allows me to do a number of different things. And one of those major things is minimizing a truck roll. So one of those major things is looking at the hardware performance, throughput, and RF utilization. You can actually look at, or I should say, it's really easy to remotely drill down and review access point performance and to check the RF background in the particular area. So when you drill down to a particular access point, that access point is located in a specific area, and you can actually troubleshoot in that specific area. So if you're in a hotel and you drill down to room 103, for example, you can look at what's happening within 103. One of those things you can look at is CPU usage. You can see how the actual access point is performing. You can look at memory usage, and this is really important from a customer standpoint, but from also a hardware manufacturing standpoint. We can quickly identify if we believe there's a problem with the CPU or memory or something's happening there. We can look at these numbers and have an idea of like, okay, something's going wrong here, or we need to make a change or something like that. So it gives us a lot of insight, and it gives you as a customer or an installer insight as well. You can also review channel utilization in several different ways. You can look at it. You can look at throughput by band, meaning speed by band. So I can look at it from a 2.4 gigahertz standpoint, 5 gigahertz, or even 6 gigahertz. I can look at throughput. I can look at channel utilization by band. So I can actually look at channel utilization as a whole to say, okay, is there any issues on 6 gigahertz, 5 gigahertz, 2.4 gigahertz? I can look at channel utilization. When it looks at channel utilization, it's looking at Wi-Fi devices and non-Wi-Fi devices. The best example of that I can give is like a microwave, for example. That would be the best reference to give for this webinar. I can drill down even further and look at channel utilization by band, again, like 2.4 and 5. We'll have 6 gigahertz. It's not added into this screenshot yet. We can also look at it by channel. So I can look at the different channels. So these are 20 megahertz wide channels, 40 megahertz channels, and 80 megahertz channels. And I can look at channel utilization when I run my mouse over that particular channel and channel width. It will break down what I'm seeing: Wi-Fi utilization, non-Wi-Fi utilization, and total Wi-Fi utilization. So it allows me to look at channel utilization per access point in a specific area, like in a room, for example, or apartment, or a multi-dwelling unit, or in a business, in like a conference room, for example. So cloud allows me to, have this access point, and for me to remotely access all this information and troubleshoot remotely very easily. And it gives you a lot of insight into what's happening on site without running or rolling a truck out to the particular site. Other things that we've added that you can utilize with the ECW336 is the cloud system gives you the ability to troubleshoot remotely with basically a speed test. You can check speed test of what's happening on the site. You're checking speed test from the access point out to the internet. Now what you have to keep in mind is you're testing across the internet, so it's maybe not the ISP speeds, but it gives you a good indication of, okay, am I getting pretty good speeds from this standpoint, from the access point, testing it through maybe a particular switch, through a router, or through a firewall, through a router, and then out to the internet. Are the speeds good? Or are they really, really bad? Maybe there's another issue there. Maybe it's a switch issue. Maybe it's a firewall issue. Maybe it's a routing issue. Or maybe it's an ISP issue. It allows you to start to consider and troubleshoot and find out where the problem is. You also have ping, trace route. You can ping inward. You can ping towards the client device, or you can ping towards a particular switch or to a gateway to further troubleshoot maybe if there's a speed issue. So you can start to look at, okay, is the problem between the access point and the client, or is the problem between the access point and wired to a switch or to a particular port or to a gateway or to something else. So it does allow you to ping either way, you know, inward or outward, and then you can also do trace routes as well. So we did add multiple device connectivity items to the mix to help further troubleshoot and minimize truck rolls. The other thing that we added is live clients, live client activity, which gives you a live view of the wireless clients connected to that specific access point. And it gives you information like SNR, for example, signal noise ratio, or even RSSI readings of the wireless client. So it gives you a good understanding of the connectivity of the particular client and if it's a good connection or a bad connection, and kind of the download and upload speeds that the particular client is on. And you can see in this screenshot I was testing, I was looking at my iPhone and another Apple device that was connected to it. One on 2.4 and one on 5 gigahertz. But we're giving our customers a lot of ability to be able to troubleshoot or start at a very high level and start to drill down into specifics and be able to troubleshoot on particular access points. So all of your AP configurations happen within a few screens, really. So again, this new access point, this Wi-Fi 6E access point, is a cloud managed access point. I already showed you the local GUI, and really nothing is really, you're not configuring SSIDs, wireless security on the access point, the physical access point itself. You're doing this all in the cloud interface. So you're going to do your SSID configurations in the cloud. This is that first screen that you're looking at, all your SSID configurations down to the type of authentication. If you're using Radius server, if you're using, you know, whatever security, is it WPA2, WPA3, WPA3 Enterprise, all of that is happening within this first screen. I'll quickly show you these screens within the cloud interface. Also, you can do your radio configurations. That's the second screen. You can configure on 2.4, 5 gigahertz, and 6 gigahertz. You can, select your channels, or you can put them in auto. You can select channel width, the transmit power, the output power of the radio or per frequency. So I can set that all the way up, on the ECW336, you can set it up to 23 dBm if you want to. But in most cases, you're going to set it closer to the client device's output power, which is around 11 and 17. 11 for 2.4 and 17 on 5 gigahertz. Right now, I would leave 6 gigahertz to about 17 dBm. There's still a lot of testing going on 6 gigahertz, but 17 dBm is probably the best to start with, or even trying auto is another method that you could also use. You can set your minimum bit rates, the client limits. On 2.4 and 5 gigahertz, you can discard 802.11a, b, and g. You do not have to worry about that in 6 gigahertz, so that's not there. You can set up DCS, or actually I should talk about disabling 11ax. The only time you would really disable 11ax is if you have a legacy device. We're talking about this center menu right here, by the way. You would only disable 11ax on 2.4 gigahertz if you have a legacy device connecting on 2.4 gigahertz. You can also disable it on 5 gigahertz depending on the environment that you're working with, and 6 gigahertz you're operating on 11ax. So any device that's operating on 6 gigahertz is working with the newer standard. So 11ax would be operating on that frequency band, so you wouldn't you would not turn that off or disable it. DCS, which is our dynamic channel selection, that can be enabled across the board. Client balancing can be enabled across the board. Meshing can be enabled. I think I get this question a lot. All of our access points mesh, including the ECW336. You can mesh on 6 gigahertz. So if you're in an environment that you will be meshing, but there's no 6E client devices, you can backhaul on 6 gigahertz. So you can mesh on 6 gigahertz. And say, for example, I'm a 2.4 wireless device. I connect to the access point. The data is going to transmit. My data, my 2.4 gigahertz data will transmit across that 6 gigahertz band to another access point, and then through the Ethernet port of that access point. So you're actually utilizing 6 gigahertz. You're utilizing the faster speeds that you get with 6 gigahertz and the cleaner frequency band of 6 gigahertz when you do that. So that is one of the advantages of having this particular device, the ECW336, is you can mesh on that particular device. So and then you have 0-weight DFS. That's not a concern of 6 gigahertz or 2.4. It's only a concern for 5 gigahertz. That can be enabled only on the ECW220S and the 230S. So we won't go into that too much further. You can actually do individual AP configurations. So the first two screens are really group configurations. You have SSID group configurations and group radio configurations. And then you can dive into the particular access point and make specific configurations on the particular access point. Maybe you're changing the output power, the client limit, if you want to enable meshing or disable meshing from this particular device, you can do that. You can also turn off SSIDs within the access point. So you can do that within the individual AP settings. The other thing I kind of bypassed over is PSC channels. This is on by default. You always want to use PSC channels when you're using 6 gigahertz. There's really no reason to turn it off, but we do have it enabled in case for greenfield testing or just testing in general, but you always want to leave that on. If it's off, you will cause the clients a major delay when they're doing their scanning or probing, requesting frames across available channels. You will delay your client devices when that's turned off. So you want to keep that on. That's on by default. So best practices is definitely keep that on. I think you'll cause more problems if it's turned off. So just be aware of that. So let's quickly go into the cloud demo. Let me bring that up. Let me refresh. So I'm basically logging into my cloud interface. So this is the cloud GUI. I have my organizations. I'm logging into my personal network at home. I'm not currently at home, but we're looking at this particular network. You can see this is my dashboard. I have 1 access point, 2 APs, and 9 clients on there. What I wanted to show you with this particular demo is basically how to register one of the ECW336s and how easy it really is. I'm hoping it's going to show you how easy it is. So I have 2 access points on here. I can do it in 2 ways. I can easily go to what is called the organization, this building icon, and go to inventory. And I can click register, and I can type in the serial number of the device. So the serial number can be found on the back of the access point. There's also a QR code on the back of that particular device too, and I can use the QR code to take a picture of that, and I will show that. But I simply put the serial number here. I can do it 1 at a time or multiples at a time. It's just got to be 1 per row, and click register. Once I register it, it goes into my inventory list, and then I can assign it to a particular network. So what I will do is I will register the device, this particular access point that I showed at the beginning. Let me see. Let me go back really quick. Let me just show you. This is the access point. Hopefully, there we go. It's got a QR code. I'm trying to keep it in focus. I have the background on. It has a QR code on the back of it and the serial number. I will use my Cloud2Go app to register the device into my cloud interface. That's what you're looking at right now. So you'll see it show up here, but I will also show you the cloud app. So hopefully this goes as planned. So just bear with me as I restart my screen mirroring on my phone. And I forgot to mention at the beginning, but if you have any questions, by all means, put those questions in the question area or in the chat area, and Eddie and I will try to answer those questions. So as you can see, I'm on my phone app. I'm going to go into my cloud. I'm in my Cloud2Go app, And you'll notice the little plus sign here. Maybe I'll hide this so you just see that screen. You'll notice this little plus sign here. I'm going to tap on that plus sign. It goes right to my, it goes to register new network site or cancel. I'm going to register a device. It's going to go to my camera. You can see my laptop. This is the access point we're just talking about. When I flip it over, it's going to hit the QR code and it's asking me to register the device. So this is, it tells you the type. It's type AP, model is the ECW336. That's our Wi-Fi 6E access point. The MAC address and serial number, I'm going to register it. I'll just leave it as, I'll put in the device name. And assign to a network. Now I'm going to skip this and just finish. So it should show on my screen, my cloud screen here. Let me just do a refresh really quick. Just bear with me. There it is. Okay, so you can see ECW336. This is the MAC serial number. And all I have to do is assign it to a network. Now I can do this through the cloud app or I can do this from this screen. So I'm just going to do it from this screen because I wanted to show you, it shows up in your inventory. And then you have to assign it to a network. When you assign it to a network, whatever's programmed in that network, like SSIDs, for example, radio configurations, all those things will apply to any device I assign to that network. So right now, before I assign it, under my network or my SSIDs, I have 3 SSIDs. So when I assign this access point to Slayman organization, Slayman network, it will take on these 3 SSIDs. And it will also take on these radio settings as well. So these are my radio settings. Right now I have 6 gigahertz turned off because I don't have any 6 gigahertz at my current home. But I will actually apply that. Let's see, apply. Okay, that should not mess me up for this demo. Okay, so what I will do is go back to my inventory and I will highlight this particular access point and I will assign it to a network. It looks at, okay, what network would you like? I'm saying Slayman network, highlight the network and apply. So now it's assigned to this network. So when I go to this particular, when I view the organization level, the dashboard, you'll notice I have 3 access points on there. I used to have 2. One is offline, that's the new one. And if I go into the network, the specific network, I have 3 access points. One is offline as well. So now I went from the organization level. I have 2 networks under the organization level. This is the organization level and then 2 networks. So I'm looking at specifically this network and it's saying, okay, it's waiting for the 3rd AP to come online. So it's not online. So if I click on this, it will AP list. It shows me the new AP. I can rename the AP at this point and I can look when I plug this in. When I plug in the access point for the first time, the access point will go, oh, Brian has assigned me to Slayman organization, Slayman network, pulls the configurations down to the actual hardware device, the access point, and then it will check for a firmware update and make a firmware update. And then it's done. Then it will come online. You will see the device actually come online, and then the configurations actually pop up on this view. Now you'll notice when I tap in and go into the details of this access point, there's no activity because it's not plugged in at all at this point. If I go into the detail pages, there's really no activity because it's not plugged in right now. But I can come in here and make configuration changes if I want to. And so before the device even comes online, I can come into the screen and actually make configuration changes. And then I can plug in the access point of 5 years later, and it will come up and say, oh, Brian wants me to have these particular configurations, and I can move forward from there. So that is how you would onboard this access point. Now, I will never go to the local interface of the AP because everything happens within the cloud. So let me just go to the EnGenius network. So I'm going to switch networks, or I'm going to switch organizations, and I will go into Pete's Wi-Fi 6E because he's running a Wi-Fi 6E device right now. Let's go to the dashboard. So he has a Wi-Fi 6E device. I'll just use this. This is a testing site. So just to give you an idea, this is what the access point looks like. He's operating on, looks like on channel 5 here. And I can go into the detail page of the access point itself. And we're just doing some minimal testing, but we have IP address information in here, channel information here. So I can look at specifics of the access point in itself. I can actually force an update. There's an update available. I can force that if I want to. There was a client on there right now. And the rate is at 2.4 gigahertz. That's the rate it connected at the time. If I click on diagnostics, I can even go down deeper, and now I can look at CPU usage, memory, throughput if I want to, and it notifies me that channel 5 or 5 gigahertz is disabled right now. So there's a multiple things I can do here. I can do speed tests if I want to. If I move to the right, I can do trace route. I can do pings. I can add a new ping or run speed test. I can go into channel utilization. You'll see that there's no 6 gigahertz as of at this point right now, but just to give you an idea. And then I can look at live clients as well. If there were clients connected, they would show me a list of clients. There's currently one client on board right now, and it's giving me the SNR, the RSSI, the actual throughput that's happening, download and upload. So it gives me a lot of great information. So cloud gives you the ability to onboard these access points really quickly, and then also dive into individual access points, either mass configuration, do mass configurations, individual configurations. Really, really easy to use and utilize. So what I'll do is show you the app really quickly. Oops. And I will change organizations, and I will go into, if it works, okay. Peter's Wi-Fi. These are the access points we were just looking at. Here's the ECW336. And there's a multiple things that I can configure here, change here if I want to. I can exclude it from meshing. I can, I can turn that on. I can look at clients. I can look at radio statistics. There's a multiple things I can blink LEDs. There's a multiple things I can do here on the actual app itself. Just to give you an idea of like how the app works and how it looks. We've done a really good job in regards of designing the app to emulate what you can do within the interface. I would say you can do about 90% of what you can do in the local GUI versus the cloud app itself. So let me just close that out. And I believe that covers everything for today's presentation.